Welcome to the Explainer. So, you've got an idea in your head, right? But how do you turn that into something you can actually hold in your hand? Well, that's where tools like SolidWorks come in. Today, we're going to demystify this incredibly powerful program, one of the biggest names in engineering and design.
Okay, so let's kick things off with a really great way to think about this. From designer Aryan Falai, what he's getting at here is so important. The goal isn't just to memorize a bunch of buttons and clicks. No way. It's to get so good that the software just disappears. It becomes an extension of your own mind. He compares it to driving a car. You're not thinking, okay, now press the gas, now turn the wheel. You're just driving. You're focused on where you're going. That's the kind of mastery we're talking about.
And that idea perfectly sets up our goal for this explainer. We're here to help you build the right mental framework so you can start thinking like a real designer, where the software is just a tool that serves your vision and not the other way around. It's all about that journey from, consciously thinking about every single step to just intuitively creating.
Okay, so why SolidWorks? Why does this one program matter so much? Well, let's zoom out and see where it fits into the grand scheme of things, into how products actually get made.
All right, so at its heart, SolidWorks is what we call a CAD program. That stands for Computer-Aided Design. And for engineers, this thing is, well, it's everything. It's absolutely essential. Think of it as the ultimate bridge between an idea that's just floating around in someone's head and a real physical product that you can actually make.
And here's the wild part. You've probably interacted with something designed in SolidWorks today without even knowing it. I mean, the sheer range of where this software is used is just mind-blowing. We're talking about the automotive industry, aerospace, consumer electronics, yep, your phone, and even supercritical things like medical devices. SolidWorks is pretty much the backbone of how so many modern products are designed, tested, and finally brought to life.
So let's say you're ready to start. You open up the software, now what? How does a project actually begin? Well, in SolidWorks, your very first choice is to pick from one of three fundamental environments. You can think of these as the three main types of projects you can create.
First up, you've got the part. This is exactly what it sounds like. It's your digital workbench for making a single 3D component. So if you're designing just one gear, or a single screw, or maybe the case for a phone, if it's one individual piece, you build it in the part environment. Okay, so once you have a bunch of parts, what do you do with them? That's where the assembly comes in. This is where the real magic starts to happen. You bring all those individual pieces together to build your final product. It's like taking all the Lego bricks you've made and snapping them together to see how they fit and work as a whole.
And last, but definitely not least, we have the drawing. Now this part is so important. A cool 3D model is great, but how does someone actually make it? The drawing environment is the answer. It takes your 3D models and turns them into the old-school 2D blueprints that a manufacturer needs, with every single dimension and note called out perfectly. But here's probably the single most important concept you need to grasp to understand SolidWorks. No matter how incredibly complex that final 3D object is, I'm talking a simple cube or a crazy intricate engine part, everything, and I mean everything, starts as a simple, flat 2D sketch. So that's the big idea, right? Everything starts flat. Which leads to the obvious question. How do you actually go from that 2D sketch to a 3D object? Well, let's break down the fundamental workflow. It's actually pretty straightforward. But before you can even think about going 3D, your 2D sketch needs to be solid. I mean rock solid. And SolidWorks has a really neat way of telling you if you're ready. See, if your sketch is blue, it's what's called underdefined. That means it's still kind of floppy. You could accidentally drag a line and change its size. But when your sketch turns black, that's the goal. That means it's fully defined. It's locked in, predictable, controlled, and ready for the real world. And that whole process really boils down to a super simple 4-step recipe. Step 1, pick a plane. This is basically your digital piece of paper. Step 2, create your sketch. Just draw a simple 2D shape. Step 3, fully define it. This is where you use smart dimensions to lock in the exact sizes and make those blue lines turn black. And finally, step 4, add a feature. This is the fun part, where you turn that flat sketch into a 3D object.
Okay, so you've made your first 3D block. Awesome. But most things aren't just simple blocks, right? So how do you create more interesting, more complex shapes? Well, you'll be happy to know it all really boils down to just 2 basic actions and 3 main tools.
So, what's the secret to making really complex stuff? The answer is you don't. You make simple stuff over and over again. It's so important to get this. Every complex shape you see is just a bunch of simple operations stacked on top of each other. It really is like building with digital Legos. You're just adding a piece here or taking one away there.
And those two basic actions, it's literally like digital sculpting. You really only have two choices. You can either add material to build up your shape. In SolidWorks, they call this a boss or a base. Or you can remove material, carving away to create details like holes or slots. And, you guessed it, they call that a cut. It's really that simple. You're either adding clay or taking it away.
So how do you actually add or remove that material? Well, most of the time you're going to be using one of the big three features. First, there's extrude. This is your workhorse. It just takes a 2D shape and pushes it straight out. Then you have revolve for anything circular. You draw a 2D cross-section and spin it around a center line. And finally, there's sweep for when you need a shape to follow a curvy path. Extrude, revolve, sweep. That's the big three.
So there you have it. You now get the core concepts, why SolidWorks is so important, the three main building blocks, and the fundamental workflow of sketch, define, and feature. Which brings us to the most important question of all.
Now that you can see the path, that bridge between an idea in your imagination and a real-world object you can hold, what's stopping you? The only limit, really, is what you decide to create next.